It's a exciting experience, but we'll try to make it. We'll try to make it through today. Happy Friday. Okay. So scale diagrams. Some definitions here. So scale diagram is a drawing in which measurements are proportionally reduced or enlarged by a constant factor. That's always the something that you need to remember. Everything will be affected by the same amount. Okay. Scale, it's the ratio of a measurement of a scale diagram to the corresponding measurements. Scales can be reduced like fractions. Different units are okay, but no decimals allowed. Okay, so that's important to remember. And then the scale factor. The letter we use for scale factor is K. It's similar to scale, but it's expressed as a fraction, decimal, or percent. It has no units. That's something important about a scale factor. It will not have any units in it because it will cancel out. So this is study sheet material whenever something is boxed in. So if we're dealing with pictures, blueprints, making a model of something, we use this. So for scale, we would use diagram, and we would compare it to the actual. Okay. Diagram actual. A scale factor, on the other hand, so I'm going to do it right beside it. The scale factor looks like this, and we take the diagram, the measurement of whatever is on the diagram, and we divide it by the measurement, the corresponding measurement, I should say, divided by the actual. So I need to specify, right? If you have the length of a car in a picture, you'd compare it to the length of the actual car, right, in real life. That's what I mean by that. And a scale factor looks like this. If you're making copies, if you're making replicas, right, you're starting from an original and making a new one, I use this. I use the wording as follows: new versus original. Like that. And K, then, the similar pattern as before, we would go new divided by original. There we go. So sometimes we prefer using diagram actual, like a map, right? I would say map is diagram actual, or a picture in a textbook. There's a diagram, right? And there's the actual. But if you're making copies of something, like let's say Pepsi's making a bigger can, they have the original can, they make a bigger one, the King can or whatever, I would use new original. This is better. It helps me figure out which one is attributed to which, because it matters, the order matters, right, which you put the numbers in. So there we go. And remember, no units when it comes to scale factors. Okay, no units. Convert if necessary. Convert to cancel out. Okay. We will convert if there are units. We convert one or the other in such way that they cancel out, that there are no units left. Okay, so this is for sure study sheet material. Now, I'm going to go and just talk about scale factors. Again, is it a reduction or is it an enlargement? Is it getting smaller compared to the original, or is it getting bigger, right? Remember, the scale factor affects the actual original, right? Which results in the new or the diagram, right? So we're going from actual original to the diagram or the new. Okay, so I equate actual with original and I equate diagram with the new. Okay. So when you look at the scale or scale factor, it will tell us what happened to the actual or the original. Okay, let's highlight that too. So if this is our original or actual car, and we are given measurements or we're given a scale factor that's less than 1, I should also say that if it's less than 100%, it's the same thing. There's a reduction, right? Reduction of the actual slash original. Original. So some examples, if I give you a scale factor, if k is 0.2, or if k is 2/3, because that is 0.6 repeated, right? Or if k is equal to 65%, that's less than 100%. It is less than 1 if you were to convert it to a decimal, right? So any of these scale factors would result in a reduction from the original item. Right? So I'm going to cut this here. If k is equal to 1, there is no change. Right? It's a copy, identical copy. If k is greater than 1, okay, then you have an enlargement. Of actual slash original. So examples, if k is 1.2, or k is 5/4, or k is 120%, all of these are really k is greater than 1, so an enlargement of the original will have occurred. Okay, let me just go up here, right here, just say k, if k is greater than 100%, right? Just don't forget about that one right there. K is greater than 100%, K is less than 100%. We don't really care about the middle other than just knowing the concept that if K had been 1, no change is really going to happen. You're making an identical copy. Okay. I think I want to add, I'll just talk about it. I won't make you copy it just yet. Okay. If you have a scale factor of 120%, there was a, you just need to understand there's a 20% increase, right? That's, I think you can wrap your head around it. On the other hand, if the scale factor is 65%, there was a 35% decrease because you always go from what happened to it starting at 100, because 100 is your original. If you're down to 65, that means 35% decrease. If it's 120%, there's a 20% increase. Okay, so maybe I'll add that. I think it won't hurt you. There's a 20% increase. And over here, sorry guys, it's gonna be ugly here. I'm just gonna erase that though. There's a 35% decrease. That's an important concept to understand because 100% is our basically starting point. So why don't we go to, if you see my pencil up here, this is our 100%. This is our starting point. And if we go down to 65, well, there was a 35% decrease. If we are at 120, well, we've gone up by 20%. So that's an important concept to remember. So this is just to kind of give you the background of what we're going to be doing. Once we find a scale factor, it will tell us what happened to the original. All right, let's do some math here. Let's go to page 22. Given a scale of 1 centimeter to 50 meters, notice that it says scale. That's what a scale looks like. It has the colon in between. State the scale factor used. Okay. So basically, we're gonna go over here and just say scale factor looks like this. And basically, we just take these two numbers. We write it like this: 1 centimeter over 50 meters. That's what you would do to turn it from a scale to a scale factor. That's all you do. You grab the numbers in that order and just stack them like that. We have a problem there. I have different units. I will always convert the smaller unit, sorry, the bigger unit. I will convert that to the smaller. That's usually what I do. So I'll take the 50 meters. Let's go over to the side here. 50 meters. I think we all know, right, that 1 meter has 100 centimeters. Cancel that out. And so that really gives you 5,000 centimeters. This is just an aside. Okay, I will make a note here. Convert to the smallest unit. That's usually the cleanest way of doing this. So we've got 1 centimeter over, instead of 50 meters, we'll just put in the 5,000 centimeters. And that's when you are able to cancel the units. And so the clean version is, if you want to get full marks, this is what your scale factor should look like. No units. Okay. It also asks us to state it as a decimal and percent. So we're going to do that. We're going to go comma, just turn, right? You just go 1 divided by 5,000. Oh, there's that problem. This calculator goes scientific notation as soon as it can, right? Do you remember scientific? Have you ever? This is if you're like I can't really remember. This is the trick. So you just go plus 1, just add 1 to your answer. All you got to remember is don't include the 1, right? So it's really 0.0002. That's what e to the negative 4 is. I'll explain that in a bit. Let's just write this down first. 0.0002. If you multiply that by 100, sorry, I'm not gonna multiply that by 100. I'm gonna go back up to 2e4. I'm gonna multiply that by 100 because that's what you do when you turn decimal to percentage, and that's the equivalent percent notation. I'll make another note here. That's why I left space. Note 1 over 5,000 is going to be 2 e to the negative 4. And what that is saying, it's saying 2 times 10 to the negative 4. That's what that notation, that's what our calculator is trying to tell us. Okay. So basically, to write this, you just copy this number down, and there's always the decimal is always to the right of that number. And so if it's negative to the negative 4, you're shifting this over 4 spots. 1, 2, 3, 4. See, the decimal shifts over to that, and all of the values you've created you just put a 0 in there. If you're taking chemistry, right, you'll know about this. Mr. Carrington will, or Ms. Dionisio, whoever you have for chemistry, will we'll talk about this and we'll expect you to know that. But for us, the trick is you just add 1 on your calculator and voila, you're good to go if you forget. So that's A. B, by how much has the original been reduced? We know it's a reduction, right? K is less than 100%. We know it's reduction. Okay, reduction of the original. By how much? By, here it is, 100% minus 0.02%. Okay, so you should know this one, right? It's 99.98%. That's how much of a reduction occurred here. And so this is very common with like very large, like a map, right? When you look at it on your phone, it's a huge reduction, right? From the actual area, the actual dimensions. So it's to be expected. All right. So that's how you figure out scale factors. I'm going to ask you to look at the next example here. Okay. Look at both of them. Look at the units that have been used. Look at the wording. There's diagram, there's actual, right? I want you to figure out the scale used to produce the diagram. I'm going to highlight that for you. I want the scale for A. For B, I want you to figure out the scale factor, which means you got to get rid of units. Okay. Just do A and B for now, and I'll take it from there. I'll just give you a couple minutes to figure that out. And if you're not sure, just try something. Put something down for now so we can. Not sure if you finished, but you'll get more chances. So scale to produce the diagram. Right? So remember, for scale, we want diagram followed by actual. That's how you want it. So that's for A here that I'm solving. And so one thing that you need to make sure you compare is if you're the only 2 dimensions you know are these 2. If you were compared the height of both of them, you don't know this one. So I'm going to stick with, in this case, the length of the truck. So 14 inches goes here and 25 feet goes there. That is acceptable. That is it. That's all you need in this case for the scale. Different units are okay, but you don't want decimals. If there are decimals, multiply by 10, by 100, whatever you need to do to get rid of the decimals. Okay. For B, the scale factor, in that case, we want to stack it. We want to go 14 inches over 25 feet. Can't have that, right? So somewhere on the side, you want to convert. So we're going to go 25 feet on the side here, 25 feet. We know that 1 foot has 12 inches. Cancel out the, okay, I'm going to say this. If you converted your inches to feet, it's not wrong. I just find it easier. Otherwise, you might get, if you want it as a fraction, it might not look as pretty, right? We want pretty fractions, right? So 25 times 12, what do you get there? 300 inches. So now we go ahead and replace that. We're going to go 14 inches over 300 inches. Cancel that out. And you're done. Okay. except for if you were an IAPR, you're supposed to reduce your fractions, correct? I'll show you the trick here. You know they're both even, so you can slice them in half. But grab your calculators real quick. I'll show you the trick. 14 divided by 300. If you go equals, the trick is once you've figured out the answer, you press math, the math button, and then you just keep it on fraction right there. You just hit enter, and then enter one more time. It will have reduced it for you already. If it can, sometimes it can't turn it into a fraction. So I'm sure that most of you have this anyways there. I'm not going to take marks off if you don't reduce because now I showed you the trick, right? So I don't want to assess something that you can do with your calculator because it just wouldn't make sense. So either one of these is fine. If you want it as a decimal, let's figure that out. I already know it's right here. So here's what I'm going to tell you to get ready for the provincial next year. You can go 0.05, right? If you round to 2 decimals, that 4 would jump to a 5. However, if you want that as a percentage, you need to take the original and multiply it by 100, which is 4.67%. So it's kind of tricky that way. You either turn it into a percentage, round that to 2 decimals, or you just get your decimal and round that to 2 decimals. It's up to you, but that's how you would have to answer if you wanted to get the full marks there. If I ask you for a decimal, it has to be like this. Percentage, it has to be like that. And we know a reduction happened, obviously. Maybe I'll just mention that. K is less than 100. Reduction of actual in this case. That's the wording I'm going to stick with. A reduction of the actual happened. I'm just going to put this in brackets like that. By how much? You would just go 100 minus that, and then you figure out by how much it has been reduced. Okay. C. Now we can solve, guys. I'm going to tell you this. K is like your key to figuring out all other dimensions that you might be missing in between the two. Okay, guys? Scale factor is like your key into it. Determine the height of the truck on the diagram. Okay, so now I'm not asking you for the scale factor. This is fixed. It stays like this. Every single dimension between the two is related by this, by this one of these. They're all the same. Okay, I tend to use my fractions when I work with these. Okay, I don't like to use the decimals because then I'm losing some accuracy because of the rounding. So for C, determine the height of the truck on the diagram. Watch this. I'm going to start with this formula again, but I'm going to add a little to it here. I'm going to go height of diagram over height of actual. I'm being very specific now. So what's K? Do I know that already? Yes, right? It is 7 over 150. So I'm gonna substitute that in. I know the height of the diagram. I don't know, so I'll keep that height of diagram. The height of the actual truck I know is 10 feet. And look at this right now. What's the only unit that is present here is feet, right? So your answer will be in feet. So you might have to do some converting if necessary. So let's figure that out. H, I showed you the trick, right? It's the variables on the right side. You start with a number, cross multiply, then divide. So you're going to go 10 times 7 divided by 150. and that's, let me check my key here. Is that 0.46, right? I'm just gonna double check. Because, you know, I usually make a mistake here and there per class, so I don't want it to be Friday. Okay, so this many feet. The question didn't say in inches, but let's just answer in inches. Let's just finish that. So what I do is right here, because I haven't rounded yet, I'm just going to say that 1 foot has 12 inches. That'll cancel out here. So it's basically just the answer times 12. So I'm going to take my answer, multiply it by 12. It's 5.6 inches. That is the answer to C. And make sure, like, it should make sense, right? It is smaller than the actual. D, by how much has the actual truck been reduced? We're going to go 100% minus. I like to answer this one using percentages, to be honest. It's a lot easier. And that would be 95.33. Okay. Reduced by 95.33%. That's it. Okay. I'm gonna give you some class time to work through some more questions that are like this. I'm gonna always take you back to scale factors. That's really where it's gonna, once you figure that out, you can answer anything else you want. We're gonna continue that next week as well. So the questions I would like you to, or the pages I would like you to focus on for now, let's just do 23 and 24. Okay. Work on pages 23 to 24. And I might post the key if I have it scanned. If not, I'll just have it up here later in a bit. And if you need help, I'll circulate and just give you a hand if you need to. Okay. Don't mind just going back to what was it, page 23 for you? And so I saw that most of you were. So remember, if it's just a scale, you just want to write it like this with a colon in there, and it's diagram and actual, right? So we have, how do you know to use, there's a diagram there. So this is the picture, and then there's the actual. So this is the number you start with, and then the actual follows. Because there's a decimal on both sides, multiply both sides by 100 to get rid of the decimals, right? So this is technically a scale you would want to state it like this to get 100% right on this question. You want to do that. And then scale factor. Yes, I'm using these numbers to set up my scale factor, but it's okay if you use the original values provided. What else do I want to say about this? Is, oh, notice that the diagram, that number it's a bigger amount than the denominator. So we know that an enlargement happened. We can already kind of predict that that's going to happen. I convert my centimeters to millimeters over here. I'm hoping that you know that 1 centimeter has 10 millimeters. If not, add that to your study sheet. It doesn't hurt. And so I come up with this many millimeters, I plug it back in here. So ultimately you get 190 is your scale factor, or 19,000%, right? If you multiply that by 100. For C, since it's bigger than 1 or bigger than 100%, the actual has been enlarged, right? By, you would just subtract, you would take 100, so it's 18,000 and something, right? That it has been enlarged by, so quite a bit. For D, if the nucleus has a diameter of 0.12 millimeters, determine the diameter in the diagram. So again, I would use that scale factor. In this case, it's over 1. And then you want to find what the diagram measurement is, since you know the actual, and it's just cross multiply and divide, right? 0.12 times 190 divided by 1. And your answer is 22.8 millimeters or 2.28 centimeters, whichever one. It didn't specify, so both are okay. All right. Maybe just one more before I talk about scale diagrams. So when you have something like this, you decide which two sides you're going to use to compare, because every single side has been changed by the same amount. So if you want to use the width, right? So the pink in this case, remember, if this is the original and this is the new, that's the wording I would be using. New and original. So new over original, that's really half, that's 0.5, which is 50%. You could have used the lengths, you still get 50%. Either way, it should jive, okay? So I'm going to leave that for now. If you could go to page 27, and I posted, I'm going to post 23 and 24, so you can go look and figure out if you're doing things right. There are nuances with every question, so make sure you try them, okay? Scale diagrams, you're not going to see a whole lot of them. You're not going to see a whole lot, but one on the test here and there. So this is page 27. These are the steps, really. Convert your actual dimensions using the scale, or a scale factor, I should say. Yeah, using a scale or scale factor, it depends on what you provided. You can use the shortcut, which is that diagram is k times the actual. This is just a shortcut. This is derived from k is equal to diagram over actual, right? This is derived from it. So it's not like I'm giving you a new formula. All right, draw object using your conversions in one, and then label the diagram using the actual dimensions. So this is, I'm going to show you, I'm going to be flexible here when it comes to labeling. I'll show you how to make sure you get it right every time. So let's say here, dimensions of a room are 12 meters by 8.6 meters. Draw a scale diagram using 1 centimeter to 2.2 meters. This is a scale given, okay? Not scale factors. So there are different units. You see that? I'm going to still convert using that. And you know what? I'm not going to use the shortcut because I'm not given the scale factor. I'm just given the scale. So I make this my length, and I make this my width just because of convenience. So for length, what you do is you take the scale that you're provided, you go 1 centimeter over 2.2 meters. Because remember, I'm not asking you for the scale factor, I'm just asking you to convert. And we know that the dimensions of the room, the actual dimensions, would be here, 12 meters. And so this is the length of the diagram that I'm going to figure out. So just cross multiply and divide that. You go cross multiply, divide. So it's 12 times 1 divided by 2.2. What are my units going to be in, guys, when I figure this out? centimeters. Yeah, a proportion that you gotta match, right? If I would have shown you the units here, you would have seen that they cancel out and you're left with centimeters. So that is, I'm just gonna go with my key here to speed things up a little bit. 5.45 centimeters. Okay, so this is the diagram length, the one you're gonna sketch. For the width, you do the exact same thing, 1 centimeter to 2.2 meters. And in this case, the actual width is 8.6 meters. You're going to go width of diagram like that. And then you just cross multiply and divide to get that. 8.6 times 1 divided by 2.2. When you plug that in, you get 3.91 centimeters. So by the way, this is for the diagram, right? These ones will go for the diagram. We know that because obviously they give us the actual dimensions. We want to like bring it down to something that can be that you can fit on a piece of paper. Here's where you need your ruler. If not today, then that's fine. If you don't have a ruler, just kind of go approximately. But I'm going to go with my length of 5.45 centimeters. So you just go to 5.45 is just at the 5.5 mark. That's close enough. And my width is 3.9. So you go almost to 4, right? 3.9. If you're off by a little bit, I won't notice. If you're off by, you know, a whole centimeter or I'd say a couple millimeters, I will notice that. So this is the diagram. And this is how you can make sure you get full marks. I'm going to make this my 12 meter by 8.6 meters, like that. And then next to it, I'll just say it's 4.45 centimeters on paper, and this is 3.91 centimeters on paper. So if you do both, you get full marks for that. And so I usually just have a cutout template on a test, and I just put it over yours, and if it matches, you're good to go. Right? So this is how you do scale diagrams. Okay. So what I'm going to say here is for homework for you to try. Obviously, 23 to 24, I would strongly suggest that. And so I would say 25 to 26. And 28 to 29. Now, I know some of you are going to say, like, I want to have some fun this weekend too, right? It's not all about math. I would still say for sure 23 to 24, which I asked you to start in class, finish that. Make sure that's done. Okay, so should I write that down? This one is for sure. This one I would also say for sure have these checked. And this one is, it depends on how you want to do in the class. That's what I always tell my students. If you want to really do well every time, the more the better. The more practice, the more prepared you will be. All right. Thank you guys.